What's up guys, welcome back to the next video in learning C++. My name is QDS Danny and you guys watching my channel Cryowood. Alright, so in the previous video we have created a class called base, and we've got another class drive1 which inherits the base, and here we have declared our virtual function by the keyword virtual, and here we are just defining different forms of this virtual, and we said that's polymorphism because you guys here using keyword virtual for polymorphism, so remember that. So this is one form, just say with if you guys remember function overloading and operator overloading, we have that's one form of polymorphism, and this is the second form of the polymorphism. You guys making look like one function, and here you guys design you guys writing different codes or reforming the same function, and I think this is more efficient this way. And here you guys accessing here with virtual all the pointers you guys pointing. And keep in mind in the compiler, and I'm going to talk in future videos that how the compilers in the background create something called a vtable. So the compiler comes in and creates because you guys are creating the virtual here, there is something called early binding and late binding, which I don't want to confuse you at the moment, but I'm going to discuss it in the next videos. So the early binding and late binding, when we guys comes in declares when because you guys declares virtual, and at the compile time the compiler waits for you guys to comes and describe your functions, and here's compiler quietly makes something called vtable at the background. And in these vtables, whatever you guys do, go in here, the tables of row 1, and that's a row 2, and that's row 3, because all this function goes into rows. So if you guys here, there's a row 1, row 2, row 3, they all go here in the table. So there's a 4 rows now. So our table have a 4 rows, and all of them is the compiler now pointing and binding together all these here, whatever we are pointing to the functions of the same function, because that's here say hello, and that's objects, that's all our objects here, and we are pointing to our objects here, to our function here. We are first if you guys look in here, we have class base, we created wood, which is a object, and we have another one, p is a pointer, and here we are our pointings, we are assigning this object to our pointer, and our pointers are pointing to our function. That's a virtual, that's the second one, that's say hello, that's the third one. All right, so in this video we're gonna show you guys the abstract classes and pure virtual functions. Now you guys heard of the virtual functions, but what is the pure virtual functions? Pure virtual functions has no definition in the base class. Wow, that's amazing. Now you're gonna thinking that how we cannot make a virtual function and we do not define. There is no definition, because pure virtual functions you guys do not have any definition. When abstract classes is inherited all pure, that's RE, virtual functions must be implemented, and inherit class becomes abstract as well. So abstract class, if you guys thinking what is abstract class is a class which has a pure virtual function here. So it has a pure virtual function here. All right, so we're going to go on the pure virtual function now. So you say, for example, we have a class base or class animals, or if you guys want to say change this to make it easy, we go have a class animal, for example. All right, so the first one is say hello, or say hello from the class base class animal class, for example. I'm gonna change it to make it more easy for you guys. So now we have a class animal, and that's a base class. Now we have here a class, say for example class dog. dog, and this class we are gonna access all the public member function of this here. We have a public access specifier, and we're gonna inherit the animal, the class animal, and this one also has say hello, and this from say class from dog class, for example, or you guys can put a say bark or say something. Okay, so now this class or say class, you guys can put a class puppy, and this class puppy are taking inherit from the class dog. Okay, and the class puppy hello from the class from the puppy class. All right, so now it's easy to understand. You guys come here and says class animal, and here you guys have a class dog, and this inherits from the class animal, and class puppy which inherits from the class dog from this class. All right, so all of them, the one of them have a virtual function, and this one's we are just reforming that one. As I said, the polymorphism, there is one function which has many definitions. So you guys if you guys remember in the previous videos, we said that the polymorphism is Greek word. There is a ability of something to have many forms. So here we're going to change this one as a class animal, and we are not going to put a wood, we are going to put something else, and we're going to put it as a pet. So we have a class animal, and now this we have a pointer here, or you guys can put it in different lines or one line, and now we call this pet instead of wood. And here we're going to create the two objects. So we're going to create the class dog. Our dog name is, for example, it's going to be Rex, for example. Then our puppy, which is inherits from the class dog, and we call this one for example George. Okay, so now we're gonna have a pointer, and we're gonna come pointed towards the pet, and now P is gonna say hello. Now this one is gonna go towards point towards Rex, which is a class dog, and that's gonna point towards say George. All right, so now our everything is ready, and you guys looking here, that's the best example I can give you, because that's everyday life, because the dog and puppy is animals. So the class dog inherits from the animals, and the class puppy inherits from the dog. All of them have a say hello as a function, and here we are creating the pointer, and we're creating objects. Here we are creating the object here, and the George's object here. Our pointer is pointing towards object, and here pointer, then this pointer we are assigning this object to the pointer, and the pointer is pointing towards the say hello function, which is the virtual function. And if you're gonna run, and if you guys looking here, hello from the animal class, hello from the dog class, hello from the puppy class. All right, so now we're gonna come here, and they all look good, and now we're gonna create another class, and our class is gonna be class Kate, for example. We're gonna put a class Kate, and our class Kate is gonna have a public specifier, and it's gonna inherit from the class animal. All right, so now I'm not going to put anything inside our class Cat, so it's going to be empty, totally empty, to see if we're getting any error or not, because I'm not going to create an object at the moment. So I'm going to run first, and to see if I'm getting any error, because I'm not getting any error from all I can see is from animal class, and from dog class and puppy class. All right, so what about if we create an object, for example, for this empty one, because there's nothing here, and we're gonna come, and we're gonna create say for example Kate as Fluffy, for example. Fluffy, Now there is a object, empty object here, and there is nothing inside this cat. And we're gonna run again. You're not getting any error. So you guys see here, I'm creating class, very empty class. I'm even inheriting from the public animal from this one, and I'm not getting any error and any error whatsoever. I even have a object here, Fluffy. Why I'm not getting any error? Because I've created a virtual function here, and I'm reforming, I'm describing here, but I haven't got anything here. I even have a object here, but I'm not getting any error or anything. Then the C++ might think, why people come here, programmers come here and creates some empty objects here or empty classes here. Alright, so how about if I come here and I put this one away and I put a equal to 0? What do you guys think happens? It happens because I'm gonna now create pure virtual functions. As a programmer, you guys needs to come here. Now I have created interface. Now if you create interface for any pet shop or any their programmer, whoever is not gonna no experience with C++, they cannot just come here and create empty classes here for you. Okay, so now we're gonna run, and you're gonna see that the compiler is gonna be very furious. So it says cannot declare variable pet to be abstract type, and if you look in here, abstract type animal, that's what I'm meaning. So it cannot declare variable pet to be abstract type class animal, and this is why we call these abstract classes. So now you guys should know why we call abstract classes. Throughout your programming career, you guys gonna program, say for example for NASA or for many other companies, and they want you to create interface. This is interface. Now there is no definition here. You just, all you guys gotta do, just put a equal 0. Now this is our virtual functions called pure virtual function. Now this is a pure virtual function. Any programmer or any staff from that company comes in and create here empty object here, our empty class. Then the C++ gonna throw whatever it has in its arsenal. It's gonna give you a lot of errors because it's not gonna go ahead and it's telling that programmer, hey look, this is a animal class, is a abstract class. You cannot create another one variable by the name of the pet. It has a variable by the name of the pet, you cannot declare that. Okay, so and if you guys look in here, now it's got a giving you guys error with the Fluffy to be abstract type cat. Okay, so how about if you remove this Fluffy, for example? Now we remove the Fluffy, we run again, we still got an error. Why we still got an error? Because we remove our object, because here cannot declare variable pet to be abstract type of animal. Now you cannot declare this one because this ones have a problem. Why it has a problem? Because now we have created our interface here. This interface function, now we have created our animal, and we declare this one as a pure virtual function. And now effectively we have declared our class as abstract class, that hey, you can redefine this one, but you cannot leave it empty. So say for example we come here and say void say hello from the class, and say hello from cat class, hello from cat Fluffy class, Fluffy class. Okay, so now we have created here, because all C virtual void pure virtual function wants us to create something here. We cannot leave it empty, or we cannot create empty objects here. Now we have a Fluffy, and now we're gonna come here and we say p equal to say Fluffy, and we're gonna do the same thing here, and we're gonna copy that one and we're gonna paste here. Now if you're gonna go and run, we are making mistake here, and we have to put our reference here. And if you look in here, why I'm getting even error, because I have fixed everything here. I put in the virtual table, I'm pointing it towards my table, and here it says cannot declare variable pet to be abstract type animal. And if you look in here, you guys cannot declare this one to abstract type class animal. Here we have a problem here. We have a problem here because this one has no definition. This is because we are declaring in effect that's a 0, it means you guys need no definition here. So if you guys have any definition, there is no definition, you guys can have another function maybe by another name, and you guys can declare it here. But this function by itself, C++, as far as C++ concerned, it means you guys not allowed to put any definition here. There is no definition to say hello here in the base class. That's what is called abstract base class. So if you guys hearing abstract base class, and what stands for ABC? It stands for ABC, abstract base class, and that abstract base class you guys cannot declare or anything. So you guys come here. So whenever you guys create this virtual void say hello, and especially you guys gonna put a pure virtual function, then you guys need to come here and remove this pet, because you guys don't need it. First of all, you guys don't need it, and secondly, you guys don't need this one because you guys have no definition here. The reason we put here before is because we had a definition here, but now we remove all the definition. It means we are in effect we are putting this one to put a full stop. It means 0. It means we are not putting any definition. So whenever you guys bump up to this virtual void say hello, it means it's abstract class and it's a pure virtual function. So now we have removed our object here. We are not pointing towards this abstract class. We are not doing anything. Now we're gonna run, and if you guys look in here, it works perfectly fine, with the exception we don't see the base class because our class is abstract, because as I said to you guys, is ABC, abstract base class. So now we're going to see the hello from dog class, hello from the puppy class, hello from our new class, which is the cat fluffy class. So you guys see now the power of C++ polymorphism, and you guys see the virtual functions. You guys can make your function, or can declare once and can you reuse it. You can give it to many forms. As I said, that's a polymorphism. And you guys look in here that you guys have a class dog, class puppy, class cat, which is a new class, and all of them work perfectly fine, but we don't see the base class. The reason you don't see the base class is because here you guys have now you have abstract base class, and you guys look in here because you guys need to put this one equal to 0. When you guys put the equal to 0, it means by you guys declaring your class to be abstract. So it's equal to 0, and now your class is abstract. How easy is that? And it works for a lot of places. So you guys working in the office, you guys making operating system, or you guys working for a pet shop, or you guys working for any shop, and you don't want programmers to only follow this one. You want all the programmers to use the function but cannot leave anything here, empty classes here. So this one in effect compiler prevents anyone using the empty class here. So if you guys try, if a programmer comes here and try class, for example, we put a bear, that's for example, and we're gonna go public animal from the base class, becoming a base class. And if our programmer comes here and leave it empty, so he or she can, we have a new programmer, he or she comes here and create a class bear, it doesn't put anything inside here, and follows the same here. And for a bear, you guys can put a young bear, for example, or you guys can put a cup, for example. You can put a C, for example. All right, so now our programmer comes here and create this this one here, and we can put a C, and he or she tries to point this one to say hello, and you look in here, then the C++ is not going to let the programmer to go ahead. And if he or she looks here, and it says clearly cannot declare variable C to be abstract type bear. You cannot declare it. Because why you cannot declare it? Then our new programmer is going to think why is because here is empty. You guys cannot leave it empty. You guys must implement this one. Implement what? Implement this one. You guys must put a say hello. So our new programmer comes here and put this one, say hello, and come here from bear class. Alright, so now here when we run, works perfectly fine. You guys gonna see hello from the bear class. So this is in abstract classes and pure virtual function. And remember that pure virtual function, you guys can put equal and you put a 0. That's a pure virtual function. You guys in effect call this one is interface. Easier to pronounce, interface, just remember. And your interface always empty. It doesn't matter, you guys got a constructor, destructor. You guys can put a destructor for this one, doesn't matter, but that's our discussion for the future videos. So you guys can create as many classes as you want. As you guys seen here, we have a base class, and all our classes are inheriting either from the base class or from each other. So you guys can see that inheritance in action in C++, how easy it is. And keep in mind here, now we are in effect that we have something called early binding and late binding. That's our discussion for the future videos. And now we're going to see how C++ behind the scene creates all these V tables or virtual tables, and how C++ points towards these objects and towards the functions of the same type. Alright guys, that's it for this video. If you guys like the video, thumbs up. Otherwise, if you guys have any question or comment, leave it in the comment box. Otherwise, I'll see you guys in the next video, and bye.
You